Hello, this is Galad. I'll try and attempt this question here. So as we can see in this question, we are given quite a few values. So A, which is the radius, is equal to 1 meter. Conductivity is 2 times 10 negative 3 Siemens per meter. Conductivity 2 of the second material is 8 times 10 to the negative 3 Siemens per meter, and the current is 50 amperes. Noting that the surface area through the various sections, so we have a full sphere, and the surface area would be accounted only to 1/4 of that section for at least this sigma 1 here, and that will come down to pi over r squared, noting that the surface area of the sphere is 4 pi r squared. Notice that it's the same exact thing that we have for sigma 2, or for the second portion here. And that means the S1 is equal to S2, which will be denoted as S here on after. Now notice that we have the ampere, or the current, is moving through the rod here, and then it gets to exit through two different paths. So that means that it is a parallel configuration. As you can see, it has to go through two different paths. So that means that the total current is equal to current passing through one and current passing through two. Now we know that the current density is equal to current over surface area, which means that we can bring it to this formula here. And then moving on forward, we know that the current density is equal to conductivity times electric field. And furthermore, we can just move to that formula. Now, something to note about the boundary is that the electric field due to the boundary is all proportional to, is all tangential to the boundary. That means that there is no current or electric current passing through the normal of the boundary. That means that all the electric field will be tangential. As such, we also know that the tangential electric field due to the first boundary is equal to the tangential electric field due to the second boundary, and will now be denoted as an E. Now, putting that into the format that we stated above, we can manipulate E to be I over pi r squared sigma 1 plus sigma 2, as you can see right here. And then we can plug this into the voltage formula, and we get that the voltage is equal to I pi sigma 1 plus sigma 2 A on the denominator, which is just shown in that formula here after the proper limits. Now, something to note, that why we only account dr for the dl, because think about it, if you have an electric field, the only time, or voltage, the only time it would change is if you move further away. Now note that if the voltage at this point and the voltage up above or below or behind is the same, the only time it would change is based on r, and as such, that's why we consider only r in that formula. Now, plug it into the r, which is equal to simply v over I, or v times 1 over I. We can see that the I cancel out, and we're just left with 1 over pi sigma 1 plus sigma 2 A, as noted here, and that accounts to 31.82 ohms. Now, a few checks we could do is that it does depend on geometry only, and it does depend on material as well, but it does not depend on voltage and current. That means we can assume that R is valid. Now, going to the second question here, we can see that the power is equal to the integral of the volume times sigma E squared. Now, noting that this is given in the formula sheet, the dV of a sphere and the cylindrical and spherical coordinates. That means I could just plug in the proper value, account only for a quarter of that, as we talked about above. Manipulating this and using the proper integral, we get comes down to this formula down here, after applying, of course, the proper integrals throughout. And that means that the power across the first section, which is the first boundary between Earth, which is the first boundary in the Earth onwards to infinity, we get 15.92 kilowatts. Now, similarly, the only difference between P1 and P2 would be the sigma 2, as noted here. So that accounts to 63.66 kilowatts. And as such, we can go through a quick check here. So the power total is equal to P1 plus P2, which is just equal to the values that we determined above, and that will come down to 79.58 kilowatts. Now, noting that this is the R that we came up in the first question, times the current that's given, we do get the same value. As such, we can assume that our question is correct. And this is the answer of the two questions that we determined at the very beginning. And I hope it was useful to you, and you were able to benefit from it. Thank you.
Well, this was much